Okay, so today we're going to start learning about in-step addition equations. And you'll see the word transformation and so when we're talking about equations and solving equations, it helps to picture a balanced equation. So that's what this is a picture, it's a balanced equation. So you have an x on the left-hand side. And then this blue arrow here is showing that the two sides are equal, which means whatever the x is, it's whatever the y is. So if I had a side positive on this side, what would x be? In this example, I have an x and I have 4 positives beside the x, because x is being added to 4. And I have 6 positives on the other side. So in order for this blue line to stay vertical, in order for it to keep the two sides down, these two sides be equal to each other, I have to have the same number of chips over on the left-hand side as I have on the right-hand side. So how many chips do you have in my? Right, I have 2. So x must equal 2 in order for 2 plus 4 to be the same thing as 6. So the whole idea with this drawing is that the two sides have to be equal. I want to make this as very basic, but we're going to do that on the next slide. So what we're going to be doing is using inverse properties to give x by itself. When a number is being added to x, we're going to use the opposite property. When a number is being multiplied by x, we're going to use the reciprocal property. When a number is being squared, we're going to take the square root. When a number is being square rooted, we're going to square it. And we'll come back and study each of these in detail. So whatever inverse operation you perform to the side with the x, you must also do the same to the other side to keep the balance. So let's look at some examples. So first thing we're going to do is always change the fraction to position. We've got our example. So we're going to change x minus 3.2 to x plus negative 3.2 equals negative 4. Now, who can tell me what the inverse operation is? So what we're going to do instead of subtraction, which is what we're used to, is we're actually going to be adding a positive. If you think about it as we're subtracting negative 3.2, but that's really the same thing as adding. So we're going to add positive 3.2 to our left-hand side so that we can get a 0 with our x. So we're adding x plus 0. Our goal on the left-hand side is to end up with x all by itself. So that adding the inverse of negative 3.2, which is positive 3.2, gives me 0. And that's our entire goal. Now, if we do it to the left-hand side, we also have to do it to the right-hand side. We want to keep the equation balanced or equal, so we're going to add 3.2 to the other side, to the right-hand side. So we have negative 7.6 plus 3.2. The answer is negative 4.4, x equals negative 4.4. Notice here we have x is 0, so that's just x equals negative 4. You can check your answer by substituting it in the place of the variable in the original equation and see if you end up with a true statement, the two sides of the equation equal to each other. So you're going to do a check step. I like to write a check to show you I'm going to do a check step. So this just means I'm getting ready to do a check step. So I'm going to take my answer, negative 4.4, and put it in the place of x, and then rewrite the rest of my equation to see if I get a true statement. So I have negative 4.4 minus 3.2 equals negative 7.6. When you change this to add the opposite, so don't do a subtraction anymore. And see if I get a true statement. So there's my check step, and I do need a true statement. So I'm getting my answers correct. This is an example where we're going to have to add like terms before we actually start solving. So that means we're going to combine the 5 1/3 and the 2 1/6 together before we actually start solving. You always want to make sure you put all your variables together and all your constants together on each side before you actually start solving. So we're going to change the subtraction to addition. So we can clearly see we're adding 5 1/3 plus negative 2 1/6. When we add 5 1/3 and negative 2 1/6, we get 3 1/6. So our equation, once we've added it, is g plus 3 plus 6 equals negative 9. So now we're going to add negative 3 1/6 to both sides. Remember, if we do it to one side, we need to do it to the other. We must show doing this to both sides. Otherwise, it doesn't make any sense. Because if we do it to one side, we add negative 3 1/6 to the 99, but we don't add it over here, then you're still left with g plus 3 1/6. So you still show it to both sides so that your math makes sense. Alright, so we add the 3 1/6 to the negative 3 1/6, you get 0. And on the other side, when you add the negative 9 and the negative 3 1/6, you get negative 12 1/3. And of course, the g plus 0 is just g, so g equals negative 12 1/6. In this example, I have written over here if a equals b equals a. Because you can take these two sides and flip them around, and I can rewrite this as 5 plus n minus 11 equals negative 6. So if you like to always do variable on the left-hand side. And there are some advantages to always having your variable on the left-hand side. You don't have to do that. You can solve it with the variable on the right-hand side, and it's the same thing. You'll get the same answer. So first thing I'm going to do is change my subtraction to addition. So this comes plus a negative 11. So I end up with m plus negative 11 plus 5 is negative 6. Equals negative 6. Now, I'm going to add a positive 6. Basically, adding the opposite to get 0. I'm using my opposite property or additive inverse property, which we learned about in our last unit. I'm adding positive 6 to both sides. So that gives me m plus 0 equals 0, or m equals 0. And I'm going to check to make sure this is correct. So I substitute 0 in the place of m. So 5 plus 0 plus negative 11 equals negative 6. Well, I like this negative 6 on the left and negative 6 on the right. So I play that on the left. So she's right, we're going to add negative 4, the opposite of 4, to both sides to get the opposite value of the product side. The absolute value of m plus 0 equals 3. And the absolute value of m equals 3. Now, what do you think we would do? Right. The absolute value of 3 equals 3. The absolute value of negative 3 also equals 3. So the answer here is m equals 3, negative 3. Put that in brackets. What is the inverse of square rooting something? Square. So if we want to get rid of the square root symbol, we square. And our whole goal in trying to solve is x by itself. So what we're going to do is we're going to square the left-hand side. We're going to square the square root of x because that will be the same. If we do it to the left-hand side, so we're going to do it to the right-hand side as well. So basically, we're squaring both sides. And we can check this to see if that's correct. So for our check step, we say that the square root of x, which we're saying is 64, equals 8. And that's what we're saying, so that's true. I'm sure it is. So we're going to square the square root of x, which gives us x, and we're going to square 6, which gives us 36. And then square root x squared. That will cancel the square, so we're left just with x. And if we do it to the left-hand side, we have to do it to the right-hand side. The answer is x equals the square root of 5, because 5 is not a perfect square. So the next time we'll take the square root of x squared to get x. That's the whole reason we're square rooting. So we do it to the left, we do it to the right. The square root of 144 is 12. And again, we can go through and check all of these. Up here, where x equals 36, the square root of 36 is 6. That works. Here, square root of 5, and the square root of 5 squared is 5. Check. And the next problem, where x equals 12, 12 squared is 144. So to sum all this up, I've written to use inverse operations to get x by itself from x being squared. And when x is being squared, squared. And you always, whatever you do to get x by itself, you do both sides.